Thank you. I am Igor from ZeroPool, and I will tell you about solution of Vitalik's trilemma uh, with ZK driving, data availability, and storage. So, what is the Vitalik's trilemma or the blockchain trilemma? We have three properties of blockchain. This is scalability, security, and decentralization. And we can select only two of three. And this is an issue because we need the solution for mass adoption, for scalability. We need to keep scalability and decentralization with security to provide infrastructure for solutions like Web 2 to Web 3 transformation and very large amount of transactions. So, for example, we know about Forecaster. It is using a lot of storage to store likes, tweets, and so on. But if Vitalik's trilemma is solved, then it's possible not only to provide infrastructure for these solutions, but it's possible to make Web3 Instagram or Web3 Facebook or Web3 YouTube, and also solve issue of transaction scalability to support not only finance transactions but all decentralized computations we needed. Here is a historical approach to solve the trilemma. The first one is multi-chain ecosystem. It was inspired by Polkadot and Cosmos. The idea is to make core engine and make a lot of blockchains on top of it and provide blockchain interoperability due to the same core engine. And another parallel solution is Plasma. Plasma provided high throughput and very early data availability like things based on game theory. The next evolution of ideas proposed in Plasma is optimistic rollup, and also there are ZK rollups and ZK validiums. The issue of rollups is that rollups don't scale the data. Rollups just scale the execution, and the last solution to solve this issue is data availability layer, like Ethereum Dank sharding and agent layer, Celestia, Avail. But all current data availability solutions provide only short-term data availability during 2 weeks or months. This idea is originated from Plasma when people decided then 2 weeks are enough for all, and you have assets somewhere. You will observe this object, and if you see some issues, you can interact with smart contract on L1 and withdraw your assets or fix the issues or something else. But here is an issue because all users will not store the data of the rollups where they have an assets. They should trust off-chain infrastructure who stores the data, and one of the things we are researching is how it could be solved by decentralized way. So the rollups are not enough because rollups scale only data, only transactions, but don't scale the data. So how it looks like? The data is flowed up to L1 or data availability layer. The rollup publish transaction on chain, but also the rollup publish block. to call data or to data availability layer, and this is a bottleneck. Because call data is very expensive, and data availability layer will store the data only during 2 or 4 weeks. And we cannot perform with these infrastructure recursive rollups, but we need recursive rollups if we want rollup-centric scalability. We should have possibility to deploy rollups inside rollups and so on, but until the data is floating up, we cannot do it because all data will float up to L1, and here is the bottleneck. Let's take a look at storage-centric approach, because if we should scale the storage, let's take a look at solutions who provide the storage. This is Filecoin, Rwave, and DA&Storage. The general approach of this solution is that we have copies of the data. Each copy is made unique with sealing procedure. When we add to this copy special high entropy vector. And next, nodes can mine rewards on chain with this data with random sampling. When we have a random challenge on consensus layer. And next, the nodes provide Merkle lookups of the data. These lookups could be compressed into zero-knowledge proofs, and nodes can get rewards proving that they are storing the data. But we know Filecoin and don't provide on the consensus layer high soundness for the data. This is just replacement for Web 2 cloud data storage. Rwave provide the soundness, but this is permanent storage, and it could be not so efficient because, for example, if our rollups produce a lot of data, we can publish the snapshot of rollup state, and then we can forget the data before. And then we will use the storage more efficient, and the infrastructure will spend less resources and money for maintenance. Rwave is permanent storage, so we just send the file to the network and pay fixed amount and keep the fingers crossed that the Moore law help us and the sum of all spending during all time will be less than the amount we have paid. And the DA&Storage provide configurable storage, but speaking about our problem, we need a solution compatible to rollups. I mean, we need zero-knowledge proofs of all execution. All could be happening on the consensus layer of data storage solution. It is possible. So historically, the possibility of this was shown by Mina. And in our research, we show that all storage-specific things like sealing and random sampling and so on could be made inside circuit of zk-snark, and then we can provide a proof that the data is stored and available. This is important for solving Vitalik's trilemma by storage-centric approach and rollups. And another important thing is that all these solutions are using replication. Replication means that we just copy the data to a lot of instances. and we hope that at least one of instances will be available, and the data uh, will be readable to users and network. Read Solomon codes are uh, 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 more sound solution because we can mix all the data together, blow up the data and split it to chunks, and that means that, for example, if we make 64 to 512 blow up, then any 64 shards are available to recover the data, and this approach is 10 times more efficient than just replication. Let me show how it's working. For example, we have a data blob with 4 numbers. We can represent it as values of degree 3 polynomial in specific points. Next, we can blow up the data, and now we have 8 points. Then, if we forget some points, and any 4 points are enough to reconstruct the polynomial, because this polynomial is degree 3. And that means that we can recover the source data. Here is how read Solomon codes are working. We can make blow up, and next we can split the data to the network. And then, if we can take back enough data, then we can reconstruct the source data. One of the issue of read Solomon codes in data solutions is that each node should know that the shard is corresponding to initial data commitment. And with this polynomial equation, we can easily prove it, that the commitment is corresponding to the all source data. We just represent the data as table of numbers, and calculate this table as bivariant polynomial, and then we can perform random linear combination of columns and prove that this is correct random linear combination of columns. Then, if we have enough random linear combinations of columns on different instances, we can recover the initial table. So here is minimal Zk-driven data-centric rollup. We have here data storage network with mining nodes. We have ZK smart contract on which the nodes can mine the data, mine rewards with the data, and then we can join the proofs that the data is stored and available with execution proofs of rollups, and then we get ZK proof that state transition of rollup is correct, and the block data is available. And this is enough to be sure that everything user need to use this rollup is correct and available, and we don't need then any additional data availability solutions. The main issue here that the main solution here is that recursion is unlocked. Why? Because if we provide on rollup level data availability and execution proofs, then we can deploy rollups inside rollups, and no data floating up to L1, and we can deploy rollups inside rollups if we need a lot of time, that's we need. So here are some parameters of data-centric rollup. We compute storage cost for this, taking into account Hetzner node, 15 cents per gigabyte per year, and soundness is more than 110 bits. What does it mean? If half of network is malicious, then the probability to lost any chunk of data is less than 2 in power minus 110. It's a very low number. And capacity is 1 petabyte. So next, and rollup recursion is unlocked. Next, could we reach more scalability? The single rollup instance capacity is more than 1 petabyte. But when locked rollup recursion, it means that we can build ecosystem based on recursive rollups. It's a two-layer solution when on the top layer rollup operate which mining nodes should store which data. This is important because if we have no such layer, then malicious operators can concentrate to single segment of the network. We make modeling that when one node is going offline, we need just make 2 random swaps between all nodes, and this is enough to provide high soundness. Next, we have on the second layer these rollups I described before with more than 1 petabyte capacity. Why it is important? Because with scalability of data, we can make Web 2 to Web 3 transition. So, as I told before about Forecaster, it's used its own data availability solution with also random sampling, but with replication, using decentralized high soundness solution based on Reed-Solomon codes. We can provide infrastructure for solutions like decentralized Uber, decentralized Facebook, decentralized Instagram, and maybe decentralized YouTube also. And of course, it is possible to make high soundness data storage for existing rollups when the data could be stored enough time for all users, and the data could be removed only after the snapshot of rollup is published. So when it is outdated and doesn't need it to make transactions. Here are links for our research related to this solution. Thank you for your attention. If you have questions.
Yeah, thank you for the talk. So, am I correct that to achieve like full decentralization, we not only need the proof that the data is stored somewhere, but also that the data is delivered in time to some node? So, say if I want to become an independent sequencer or independent prover or something like that, I need to have the data itself. So, could bandwidth become the bottleneck then, or what's your thoughts on this?
That's a good question. We on this layer with ZK snarks, we can prove only that if 50% nodes are honest, then with high probability the data could be recovered. But to make a fast content delivery system, we can perform additional layer. So this is another problem. It could be solved also with more classical approach, because this is very relative thing. I mean, if you are on different parts in the world, in Australia or in India or in Europe or in America, the throughput will be different. I think this is the problem, how to make content delivery system.
So I have more question from the implementation perspective. So let's say we have a ZK rollup, which is the L2 to Ethereum. And my question is, since you propose that you are not making trade-offs to trilemma, is it possible, let's say, to build a rollup that will use your DA, and how it will affect the throughput of rollup if we do not make a trade-off to trilemma? So that's the question. So basically, the question is if we can go beyond the TPS ceiling of current rollups.
Thank you for your question. Our solution solve it is not we cannot get all three properties. Of course, it's trade-off anyway. All solutions of the trilemma is trade-off. What the trade-off means in our solution? For example, we cannot build Uniswap with trillions or quadrillions of transactions per second between all accounts in this system. This we have anyway multiple segments, and ping between these segments is longer than inside. So we can take existing rollup, and we can deploy multiple of these rollups together, and all of these rollups can publish the data to this data availability and storage layer, and these rollups can use some message protocol to make transactions between them. This protocol will be slower because it needs upper layer to make the transactions. I think the solution of parallel EVM execution is solved now by another teams. Our solution is data-centric. So thank you for your question. Any more questions?
When you talk about transition from Web 2 to Web 3, how you're going to evaluate the significance of keeping data, because of course maybe some data are just computer logs, maybe they are crucial for some point of view, but maybe not so strict requirements than, for example, financial data, especially when we talk about banking, or maybe some personal data of the citizen and so on. And Vitalik also in his last article said that he is going to create like a scale from the financial on the one kind of the range, and the data it's like the latest tweet on another, because we can put data in a different graduation, and some of them should be really have a very strict protection. Maybe it should be backed on multiple devices across all over the world, and some could be considered not strong. It could also make a less so strict requirements for infrastructure if we would consider any piece of data as something very, very significant. We can really end up with resources anyhow. How you are going to solve the problem in your solution?
Thank you for your question. Very nice question. In our architecture, the soundness is very cheap. What does it mean? That means that if the data blow up is 8, then we have very high soundness. It's okay for financial tools. But if we have, for example, soundness 4 or 2, then soundness is low. So that means that for our solution, it's better to provide on consensus layer soundness more than 110 bits for everything. Thank you.